This is probably the final video in this series, and after all of that setup, okay, we are finally ready to connect to the database using R, and I will demonstrate in this section here how to use some syntax from R's DBI and ODBC libraries to do some navigating around in the database and create a database table. And I will preface this by saying that I know we're about a half an hour, maybe 40 minutes deep into this video tutorial already, and that's kind of a big build-up for what I'm about to demonstrate here, which is something really simple, but sometimes simple things can be really helpful, so I guess I'm hoping that this will be one of those things. And first thing I'm going to do is come over here into R and just show you the libraries that I'm using. So I'm using DBI and the ODBC libraries. Okay, and I'm going to skip around here a little bit because the next thing that I want to show you is the connection string. So using these two libraries, the method that I'm using to connect to my cloud, MySQL database, is dbconnect. Okay, and dbconnect requires a driver. It also accepts as arguments the username and password, so the database credentials, and then the database host. And so that's why I wanted to do this line here first and show it to you, because now I'm going to toggle over to my Google Cloud platform and show you where you can get this host information. So back in the overview of my MySQL instance within my project in the Google Cloud platform, notice here we're just on the overview tab, and there's a little section here that says connect to this instance. And since I've configured this database instance to be accessible over public IP, it's got the public IP address for the instance, and that's what I'm going to use here as the host in this connection string. Right, and notice that I've left my database credentials blank, so I'm going to execute this line away from the video and get the connection string up and running. So having substituted my database credentials in for these blank spots here with username and password, and having executed this line here, I've created an object called CN, and we can see up in the workspace that the object is a class MySQL connection. So I've successfully connected to the database. And just one more quick thing I'm going to do, just as a follow-up to connecting to the database for users that might be interested in this functionality here. There's a dbGetQuery method that will pass a SQL query up to the database and return a result. And so in this line here, I'm just going to ask it to show the grants, meaning I'm going to just show the permissions that this user has on the database, because I want to create a database table, so I'm going to make sure that I have the proper permissions to write to the database. Okay, and the result for show grants shows all the grants that I have for this user on the database: select, insert, update, delete, create, drop, reload. So looks like I can do the things that I want to do on the database, which is good. So the next thing that I'm going to do here is bring in some of the data from the Paycheck Protection Program. This is the CSV data that I talked about in the very first video. So I'm going to read these data into the workspace. They're not huge, but they're rather large, less than 1 million total observations, I think, but several fields. So yeah, 661,000 records on 16 variables. And so I have this object, which is a data frame, right? Just verify that PPP 150 plus, right, is a data frame. That data frame has some fields: loan range, business name. This will be a little bit easier to see if I do like this. And then we can just kind of see a couple of the observations here. So this is, not critical for the current purposes, but it's kind of interesting, these paycheck protection loans. I think in the first video I might have misspoke, but what's going on here is that for entities that accepted more than $150,000 worth of support through this program, you don't get an exact dollar amount for what they were offered in terms of COVID relief. You get a range, and there's a separate set of data that I also have that was pulled from the same place that has the paycheck protection loans that were made less than $150,000. And so for those loans and those entities, you get an exact dollar amount. So there's a little bit more information on the smaller denominated loans. Okay, so with these data, what I want to do is write these data to a database table. Okay, and this is fairly simple. DB write table is the method, and using that method, it accepts the arguments connection, so that's my connection string, that's the object CN. Then you give it the name of the database table that you wish to create, and then you give it the data frame that you wish to create that table from. Okay, and there are two additional optional arguments to this DB write table. There's overwrite, so you can set overwrite to true or false, and you can set append to true or false. And so if you are writing to an existing table, you can choose whether to replace that existing table or append it using those two options. But when creating a new table, you don't have to specify those options. I suppose you could, but you don't need to. And I've got a little bit of syntax in here that's going to time this operation, mostly because I'm not exactly sure how long it's going to take to write 600,000 records worth of data in 16 fields, so I'm kind of curious. So I want to see how long it's going to take to write those records to a database table. Okay, roughly 2 minutes and a couple of seconds later, we have our database table written up to the Cloud MySQL Database. And so just to summarize here, in R, we use the DBI library, the ODBC library. We established a connection to the database using dbconnect method, and the driver, the R MySQL package has a MySQL driver. We provide that connection with some database credentials and some information about the database, connect to the database, and then use DB write table to create a new table from an R data frame on the database. Now, the very last thing I'm going to do for you guys is to answer a question that I can hear a lot of you asking, which is, well, if you have all of these data already organized in CSV files and you want to work with them, why do you need to push them up into a database from R? Why not just read them into your R workspace and start working with them? And the brutally honest answer to that is, I just wanted to see if it could be done. Basically, for this tutorial, I just wanted to know that it could be done, and I think I've demonstrated that you can create a cloud SQL database using Google's cloud platform, and you can use R to connect to that database and interface with that database, and you can use R to do things like read data from that database and write data to that database into tables. And that's really my main motivation here, was just to confirm that it could be done. But I can think of some reasons why. So right, it's something, I did it because I wanted to show that it's something that can be done. But the question is it something that should be done? And I don't have a great answer for that, but I do have some suggestions, and one of those suggestions is kind of like this. First of all, these EIDL data are fairly large, and there were 3 different CSVs worth of EIDL loan data. I don't know why I put 3. I'm going to try 2. I'm just going to read these in and demonstrate that these have a lot of data in them. And the point of demonstrating this is to say that these data are not huge. They're not impossible to work with in R, but they can be a little inconvenient to work with in R. Like, it takes a little while. It takes a couple of seconds to read them in, and if you wanted to work with them all at once, it might be slow. And so it's nice to have them in a table that you could query and bring down smaller pieces of data so that you don't have to have so this EIDL1, this first CSV file that's provided by the Small Business Administration, I think it has close to 1 million records on something like 29 variables. Once it loads, we'll be able to confirm that. The same with this second CSV file. It's also got close to 1 million records on 29 variables. So the data aren't prohibitively long, but they are pretty wide, and 1 million records on 29 variables is a lot of data for R to be chewing on at one time. So organizing these data into a relational database in the cloud is kind of nice, because if I wanted to conserve on memory and I had some analysis that only required maybe a handful of states, I could just bring in the data that I want to work with into the workspace, and I don't have to hog memory by trying to read in a ton of data that I'm not going to use. As you can see, we're still waiting for this second CSV file to load. So R is already kind of choking on these data a little bit. There we go. So I was right about 995,000 records, 994,000 records in this one. Probably the same for the third one. So if you put them all together, you'd be dealing with about 3 million records on somewhere between 38 and 40 variables. So you'd have an awful lot of data if you were trying to work with it all at once. Having that data in a relational database, one thing it does for you is it allows you to just bring in what you want to use, state by state, filtering by date, doing things like that. You can bring smaller chunks of data into your workspace, and you can work with it pretty efficiently.